In this lesson, we're going to talk about the three methods for transferring heat, which are conduction, convection, and radiation. First, we're going to talk about conduction. Conduction is the process by which energy is transferred by heat through a material between 2 points at different temperatures. Okay, so for conduction, you have to have two objects. So here's object number 1, maybe it's at 20 degrees Celsius. Then you've got object number 2, it's at 80 degrees Celsius, so it's a little bit warmer. Okay, for conduction to work, you have to have something connecting these two. They need to be touching in some way. Okay, so maybe you've got a metal rod or a metal pipe. Okay, and therefore the heat, okay, remember heat is an energy. The energy can go from the hotter to the colder until they reach thermal equilibrium. Okay, now they have to be touching, and the heat has to travel through this material. Okay, so it's got to have some conductivity. The greater conductivity is attributed to the ability of the electrons to move more readily from atom to atom. Okay? Metals are good conductors because their valence electrons are freer to move than in other types. Now, some examples. Okay? So say you've got a range. Okay? So that's the stuff on top of your oven where you put your pots and your pans. Okay? And you've got a pot of water on top of it. Okay? So an example here would be the range is heating up the pot. Okay? They're touching. Okay? Literally, they are just touching right there. So it's going to heat up. So if you're cooking something in a pan, that's an example of conductivity because they are touching. Now, when you look at this pot, okay, you're going to notice something about it. Well, it's metal. It's a good conductor. All right? However, the handle is going to be made of an insulator, something that does not conduct as easily. Okay? So that when you touch it, it doesn't hurt you. Okay? Another type of conduction. Okay? Say your hands are cold and you're at a football game. You could go buy some hot chocolate. Okay? Then you've got the cup with your hot chocolate inside of it. And, you can wrap your hands around it. And the heat from the hot chocolate is going to get into the cup, okay, and then it's going to go from the cup into your hand all through conduction because you're touching, okay? All right, let's look at the next one. Next method is convection. Convection involves the displacement, okay? So it's going to get moved out of the way of cold matter by hot matter, okay? So let's take, for example, you've got a flame, okay? So you've got a candle, okay? And then you've got a flame on top of the candle, all right? So what's going to happen here is the air that's right above this is going to heat up, okay? And then what's going to happen next is that air is going to rise up. And then as it gets further away, it's going to start to cool down because there's other cool air around it. And then it will fall back down, okay? And then as this air rises up, other air replaces it, and you get some circulation going there, okay? So that's an example of convection. Now, we know that air is a good insulator, but convection allows heat to transfer from one area to another. So what does this mean? So let's say we've got your house, okay? And this is the inside of your house, and this is the outside of your house, okay? And you've got a wall on the inside, you've got a wall on the outside. Air is an excellent conductor. Air is an excellent insulator, okay? So you'd think, the heat's not going to escape, the heat's not going to leave the inside on a cold winter day, it's going to stay in here. Here's the problem. You've got this little air particle right next to the inside. It's going to heat up, and as it heats up, it's going to rise, and then it's going to come around and fall back down as it cools because it gets closer over here to the outside, and then it's going to go like this. And this circulation of the air, this convection, is going to allow heat to transfer. So one way to slow that down is to use something we call insulation. And basically what that is just stuff you put in here, okay, to make little gaps, okay, so that it can't circulate as broadly, okay? It can only circulate in these little tiny gaps here, okay? So you're still really using the air, okay, but all this little spaces are keeping it from circulating around. All right, so when is convection a good thing? Okay, well, let's go back to heating up that water on the stove. Okay, so the coils are touching the pot. Fine, we've got conduction. And then the pot is touching the water. Okay, so we've got some conduction right here. But it's only touching this water down here. It's not touching the water up there. So how does the water at the top get hot? Well, as this water gets hot, it's going to rise up, okay? And then after it gets to the top, it's going to be closer to the air, so it's going to cool down, and then it's going to fall back down, and then it'll heat up again. And that is how the heat circulates throughout the pot of water, okay? So conduction right down here, but convection within the water. Last method, okay, radiation. Oftentimes we hear radiation, we think that's not good. Okay, radiation encompasses a lot of things, and there are a lot of them that are good. Okay, objects that absorb radiation have their particles speed up, and therefore their temperatures increase. Okay, and objects that emit radiation have their particles slow down, and therefore their temperatures decrease. So an example, well, you can get radiation from the sun. Okay, and yes, it could be bad radiation, but it could also be something good. It could be the sun coming down, and you've got a greenhouse down here, okay, and it's heating up this greenhouse, okay. Another example of radiation where it is doing something helpful for us is in your microwave, okay. In your microwave oven, what happens there is you've got your food on a plate probably, okay, and it starts out kind of cold, and what happens is there's some water particles in here, and as the radiation is emitted from the microwave, those particles speed up, and as they speed up, the temperature increases, okay, and the food cooks.